Hello. In this truss, we are going to identify these members, GH, GK, and KL. You can see them here, here, and here. I'm going to show how to do it in one effective way using method of sections. So method of sections means that you can cut 3 members and still be able to solve it for all of the members that you cut. So we are going to make a cut right here. That is going to help me find members KL, KG, and HG. So what I'm going to do, I'm going to rewrite this part of the truss in a separate free body diagram. It's important to understand that you can do the same, you can solve the truss using the left side as well. I wouldn't recommend it simply because it involves extra steps. These steps are the reactions. You will need to know what is the reaction at joint A and what is the reaction at joint L. I don't want to do that. I'm going to save time, so I'm just going to rewrite this truss over here. So we are going to have joint I, joint H, joint J. We're going to have K over here, J and I. So this is H. So since I cut it over here, I'm going to create this piece over here that is going to denote my member HG. I'm going to draw it in compression, in tension, because I don't know what it actually is. Every time we don't know what the member is, we always draw it in tension. And we have KG going this way. And we have another member, KL, going this way. We, of course, will need geometry. This part over here, GH, it's the ratios for this triangle is going to be the same as the ratios for this triangle. It's going to be 12 by 8. So 12 horizontally, 8 vertically. And the hypotenuse is simply going to be Pythagorean theorem. So 144 plus 64, root of 208. So now we are able to write the 3 equations that are going to help us find members GE, GH, GK, and KL. So the first one is going to be summation of forces in the x direction. In the x direction, we have negative KL, and we do have the x component of the member GH. It's also going to be in the negative direction. So negative GH times, from the geometry, we can see that the ratio is going to be 12 over root 208. And that equals to 0. Now we're going to do the summation of forces in the y direction. It's going to be member GK and the y component of the force GH. The y component is going to go up, so plus GH times, now we're going to take the vertical component of this triangle, which is 8. 8 over root 208. That equals to 0. So we have three unknowns, and therefore we need a third equation. Our third equation is going to be the moment equation. So now we can take the moment around any point we would like. The easiest way would be to take moment around point K, simply because there are 2 unknown forces that are going through this point, which means that this force is going to not contribute to the moment around point K. So we are going to take this part over here. So the moment due to the force GH is going to have 2 components, the x component and the y component. So the x component is going to be GH times 12 over root 208 times the moment arm. The moment arm is going to be from the x component, which is right here, and it's going to be 4 meters, 2 meters each, times 4 meters. excuse me, it's actually times 2 meters because we're only going to go up to here, times 2 meters. This is going to create counterclockwise moment because we're going to go around this way, around point K, and counterclock is going to be positive moment. Now we are going to find the moment around point K due to the y component. The y component is also going to create positive moments, so plus gh. In this case, we are going to do the vertical component, which is 8 over root 208, times the moment arm from point K to point H, the perpendicular distance, which is going to be 3. Now that all equals to 0. We have 3 equations and 3 unknowns, and we can solve for them.